Angle between a line and a plane in the Cartesian form, and the definition we have already done it. The angle between a line and a plane is defined as the complementary of the angle between the line and the normal to the plane. Now, earlier it was in the vector form, now in the Cartesian form. Now, let equation of a given line be x minus x1 upon L, y minus y1 upon m, z minus z1 upon n. 1 and equation of a plane be ax plus by plus cz is equal to 0. Now, we are already knowing by the definition, the angle between a line and a plane is defined as the complementary of the angle between the line and the normal to the plane. Now, if theta is the angle between line 1 and plane 2, if theta is the angle between the line 1 and plane 2, then 90 minus theta is the angle between the line 1 with direction ratios L, M, N and normal to the plane whose direction ratios are A, B and C, whose direction ratios are A, B and C. Now, cos minus theta is equal to AL plus BM plus CN upon square root of A square plus B square plus C square multiplied by the square root of L square plus M square plus N square, or sin theta is equal to AL upon with square root of L square plus M square plus N square. Now, required formula for angle between a line and a plane, angle between a line and a plane in Cartesian form.